Good evening and welcome to Highlands Astronomical Society, live observing webcast from Benview Observatory in the Scottish Highlands. My name's Eric Walker and I'm your scope pilot for tonight. We have a live chat host, Dave Davidson. However, he's having a little bit of problem with the actual live chat on YouTube. But this is a test session. It's our actual final test session. And if anyone else can start using the live chat, that would be most helpful. We've got Rebecca Walker already using it. I can see there are a few others that have joined. And it'd be great to see who's actually watching. Tonight, we are probably having a little bit of a random observing session. In the future, we intend to have themed and structured observing sessions. But what we're doing is, tonight we're really testing out the equipment to see how far we can go. Now, I'm just going to pop my head out my observatory, and you'll be pleased to know the skies are clearing. And I can see quite a few stars in the final dimming twilight. Now, I've also set up stellarium in the background, and this is a real push on my laptop. It will push the processors quite a bit, so I'm hoping I can use them, and that way I can then help guide you guys around the sky and show you what I'm going to point my scope at. Okay, so I'm going to try stellarium, so just bear with me. And here we go. I now have stellarium and it's pointing to the sort of northwest, where you will see the very well-known asterism, the Plough. If I join the dots, I think you'll see it much more clearly. I'm going to take the dots off it. I'm going to point to a star called Mizar, and this star is in actual fact a double star. And if I zoom in on it, this is hopefully what you'll see, without the labels of course. So I'm now going to go across to my scope, and hopefully my scope is pointed at it, and you will see a double star sitting in the middle. Okay, so here we go. This is the first ever webcast telescope observing session. This will test us out. Okay, I am hoping that you can now see the double star that I showed you in stellarium. I'll zoom in. That's really closely zoomed in. I've got a little bit of distortion simply because there's still a bit of high hazy cloud. If anyone can let me know whether they're seeing things okay, that would be great for me. I can see it on my iPad. I'm just hoping that it's coming through to you guys okay. The next thing I'm going to do is I'm going to stick with the double star theme at the moment, because there's a really bonny double star. It's one of my favourites. I'm going to point my scope south, and you'll notice here I've got 3 bright stars in the frame of stellarium, and if you look south yourself, if you happen to be able to look out, you will see three bright stars that form the shape of a triangle. It's actually called the Summer Triangle, and it consists of the stars Deneb in the constellation Cygnus, Vega in the constellation Lyra, and Altair in the constellation the Eagle. I'll draw the little sticks in. That hopefully will let you see where they are. Now, in the constellation Cygnus, Deneb is the tail of the swan, and if you proceed down, you'll see it looks like a cross. It looks like a cross. It's sometimes called the Northern Cross nowadays. The horizontal or the near horizontal line of stars is the swan's wings, and the rest of it is its neck and head. I'm going to zoom in on this star here. I'm going to take the things off, and this is a beautiful double star called Albireo. I don't know if I'm pronouncing that right. Now, Stellarium doesn't do it any justice whatsoever. So what I'm going to do now is I'm going to move my scope towards it. You may hear some whirring in the background, so just bear with me. This is actually quite exciting for me. I just hope it all goes well. I'm actually working in a dim red light because I'm in the habit of not wanting to lose my night vision. But I'm kind of guessing when I do this it doesn't matter so much. But we'll see. Right, that rumble you're hearing is me turning the dome of my observatory. Okay. Have we found anything? Oh, we have. Right, I'm going to go back. Oh, I've just realised I didn't change the screen to Stellarium. Well, there you go. You see, there's all learning for us all here. Oh, hello, Howie. How are you doing? Oh, and Rona. Good. Right. What you should see on your screen now is the double star Albireo. So that is the head of Cygnus. I'm going to zoom in a little bit, and I'm not sure whether you can see the colours. I've possibly overexposed this a little bit, so we'll just bring it down. The two stars, there is a very large creamy yellow one, and there is a tiny blue, very, very blue one. Now, the atmosphere is a little bit thick at this moment in time, which is why you're seeing these stars jumping about. It's like looking at a brick in the bottom of a swimming pool, but that's what happens. That, if you were just looking at these, just looking at stars with the naked eye, you would be seeing them twinkling, and it's the fact that the light is coming from the stars is coming through the atmosphere, it causes them to twinkle like that. When you look at them in a telescope, it just exaggerates it. I'm just wondering, I don't know whether anybody can see the difference, the subtle difference in colour. Ah, good, Rona, thank you. Thank you for letting me see that. The reason I can talk, I can see your comment, Rona, is I've got an iPad sitting on the top of a rubbish bin inside my observatory here, and I can see you guys comment, so this is maybe another way where I can interact with people who are watching. Probably all right when there's only half a dozen people like there are tonight. If it ever went up to 30 or 40, it might get a bit difficult. And I can see the colour, you're absolutely right. I can just see the colour on the on the screen as well. The small one is distinctly blue, Rona. What I'll need to do is practice my settings so I can sort of dilute out the ultra bright centre of the possibly of the white star. I'm juggling many things. I should be used to it by now, but yeah, I am. At the moment, though, I've got a good headset now. So and Howie will know why I've got a good headset because we just had a fantastic Orkney International Science Festival, and Martin de Vries, who effectively led the technical team, convinced all of us to buy good microphones, headsets, and lighting. Thanks, Rebecca. Now that's good. That's good to know because that's a technique that I can use is to, bring out the colour by zooming in. That's cool. Thank you for that. That's exact. That's. I think you're right, Rona. It's. If you look at the edge of the star, I think you probably see the creamy yellow colour that you tend to see when you're looking through an eyepiece. I wonder if I can. Maybe the brightness is too high. Yeah. Anyway, I'm not going to overly muck about with it. Well, that actually looks. When I make it smaller, I think that blue colour comes out better. Okay. Right, I can't remember. What did I have in my list? Can you remember what I had in my list of things I was going to show you guys? I want to do something perhaps a little bit more challenging. Now, is M13, that's the great globular cluster in Hercules. That should be up by now. Right, I'm going to go to Stellarium, and this time I'm going to try and remember to let you guys see it as I'm using it. Okay, so here we go. Right. Hopefully you'll have Stellarium and Alberio should still be in the centre. Thanks, Rona. That's good. I saw on my laptop it looks better, and that's good. Thank you for confirming that with me. Thank you. That's the good. Double cluster, Uranus and Andromeda. That's good. I'm actually looking forward to seeing Mars. I just hope. Well, I think it will be high enough. I've got a tree just in an annoying spot in my garden, but I'm really looking forward to having a go at that as well. Right, I've got Alberio in there. I'm going to zoom out, and I'm going to try and find the great globular cluster in Hercules. It's bad enough finding it in the sky. Oh, I see it. Right. If I put the wee sticks in, right, Hercules is the upturned trapezium. That's Hercules' sort of torso. And just about, let's see, there, I am going to try and zoom in. Now, I wonder if you can see a faint smudgy thing on the right hand side of his torso. I'm going to zoom in, and there it is. Oh, too big. Too big, but there we are. The Great Glob Cluster, one of my favourites that I like photographing. Okay, so I'm going to try and find this on my scope. So again, just bear with me. I don't know whether you can hear all the whirring and rumbling as I move the scope. Not physically, by all done by electronics and motors and belts. So, scope's now moving. Of course, it's on the other side of the meridian. So that's me turning the roof. So that slot is hopefully pointing. Okay. Is there anything there? This is how you test your alignment of your scope as well. Okay. Okay, that looks a bit blank at the moment. Right, I'm going to let you see what I'm seeing, which is absolutely nothing. But I'll let you see. I now have to work out how to find the great globular cluster when I am doing this with you. Oh, crikey. That was rather overexposed. I'm pretty sure I shouldn't need long exposures with it. I'll put it up to 3.5 seconds. But I think it's just a little bit out of alignment. So again, just bear with me and I'll try and find it manually. Huh. Of course. It could be that there's a little bit of cloud. I'm hoping not. Right. Right, guys, I'm going to put the... Aha, there it is. Can you see it? I'm going to put the exposure up a bit. I think that's all it needs. Right, I'm going to go up to 20 seconds. So it takes 20 seconds for the camera to expose long enough to pick up what we call faint fuzzies. Right, I know it's there. I saw you. Oh. Slightly overexposed, I would say. I'm hoping that you guys can see this. Now, it takes, I've got it set for about 18 seconds, so it takes 18 seconds to refresh the frame. Dave, if you can remember when we were in the observatory last year, we found M33 and M1, the Crab Nebula. I think I had this exposed for about a couple of minutes. Rona, there is something. There was something. It's oh, there it is. There it is. I'm just going to zoom in a little bit more. It's, I wouldn't say it's particularly well defined at the moment, but that could be all to do with focus and all kinds of things. And as I say, I'm just kind of experimenting just now, but I think I've definitely got something there. Okay. There's all things you can play with on this thing, and the risk is that I do something and absolutely wreck it. Right, tell you what I'm going to do. I'm actually going to give this 44 seconds worth of exposure, so I'll have a look at anything you've been typing in, guys, while it's waiting. Rebecca can hear the scope, but very faintly. Very good sound. It is actually good when you own this thing and it actually moves the way you want it. Yeah, rather blue. You're right, Rona. And I think that's to do with my balance settings. I'm going to dim that down a little bit. See, when I do my astrophotography, Rona, those settings, it doesn't actually matter. The camera captures in what's called a raw format. It captures just raw data. All that does is control what you see on the screen. Now what I'm using is the screen display to webcast these objects to you. So I think I will need to practice it a little bit, but anyway. I can see it, but it's not bright enough. I can see the key stars in this globular Rona. So it's got another about 8 seconds to go before the next frame. So hopefully we're there. Now that's a classic of where I actually knocked the scope. Now it looks a bit green, but I think you can... Oh! Now, I'll tell you, I'm not far away there, Rona. Just let me see. I think you can start to see the sort of three-dimensional shape. In this great globular cluster, there is a structure. It's not a structure, it's a shape. It looks like a cross. It's sometimes called a propeller. Some people describe it as a propeller. And I think I've managed to get that. Yeah, thanks, Rona. This is the type of feedback I'm reading. What it actually looks like, it looks like pretty close to what I'm seeing in my laptop screen. It's not far away. The iPad, I would say, comes over slightly greener than my screen, so that's something I have to bear in mind. How do I get rid of the yellowy colour? Is that... Does it need more blue? It might need more blue. Oh my goodness, this is where you have to go back to your early secondary school art and remember what your primary colours and secondary colours were. Dave, you're an artist. I'm sure you could help me. What's going? I'm going to give it a bit more blue. Oh, that's not too bad. I'm going to try and zoom in a little bit on this, guys. Rona, do you want to type in and let the folks know what the Great Globular Cluster is? Oh, I think it's a bit over zoomed. Yeah, I'll zoom to 50%. That's not bad. Aha. Now, guys, I'm thinking I'm quite pleased with this one. I've put it full screen. I've definitely got the blue-green balance a bit better. Cool. That's actually... I am pretty pleased with that. Can you see the sort of... Yeah. And they're very old, Rona, I think, aren't they? Thanks, Rona. Yeah, I think I'm pretty sure it's Martin. Martin does talks on the... Martin de Vries, he gives talks on globular clusters. And he calls them wandering something or others, and I can't remember what it is. I'm sure they're very old. Thanks, Rebecca. That's good feedback. Are you enjoying this, Howie? This was a cluster I was tempted to talk about at the science festival, but to be honest with you, it's tricky. It's a tricky find with binoculars. Whereas the other two that I was talking about, the Seven Sisters, the Pleiades, and the double cluster, they were pretty good. I don't. Oh, have you tried, Rona, to select 1080p, which is the highest resolution? I've got this set so that it is actually, well, it should be being webcast in 1080p. I'll just check if I'm doing that. Yeah. The other thing, of course, is that as I start to extend the exposure, if there's any slight tracking anomaly, it'll go, it'll streak. Although I don't think that's okay. I can't see any streaking. I'll tell you what it is. I don't think I've collimated. I don't think I've lined up my mirrors and the camera perfectly. I think that might be contributing to the slight out of focus look. Thanks, Heavy. Yeah, and it is slightly murky. The forecast is for about 11 o'clock or so for the moisture to just fall out of the air. And of course, at this time of year, I tend not to start imaging until probably before midnight. I need the very faint things that I tend to image. I can't afford to have any interference from atmosphere. Thank you, Rona. Very good. Right. I'm going to just give it a little bit more blue just to see if I can make that better. Somebody's just texted me. Okay, I just got a text message from Dave there. He's struggling to get onto chat in YouTube. There's again another learning for the club when we do this. I think we might need to just either send out or give a link for people to how they set up, how they can gain access to use the live chat in YouTube. It's something to do with you have to register for it and have a Google account as well. So again, thanks, Dave. That's the poor problems that you're going through tonight are going to benefit other people. Oh, variable stars. Yeah. Anyone that's looking at this, Rona is our variable star expert. Rona has shown me some of our observing logs from years gone by, and you've been into variable stars for quite a while, haven't you, Rona? I've got to say my little setup here is working for me. I can see the chat, and it's allowing me to comment on it. Now, you might be, I don't know how you're thinking it. You might be thinking that I'm talking very, a long time after you've typed it. The reason for that is there's a 20-second delay roughly from my webcast on my computer being able to be seen by you guys. So when I see your comments, I've got another 20-second delay. So, yeah, 1971. My goodness. 71. What was I doing in 71? Why was it secondary school? Secondary school. Second year was I? Third year maybe. Maybe third year. My goodness. That's such a long time ago. We've got a subscriber to the channel already. Gary Fairley. Thank you, Gary. You obviously must be thinking this is worthwhile. Okay. I'm going to spin my observatory dome round. I want to see if I can see Mars. I've got a horrible feeling Mars is behind a willow tree which has gone absolutely mad in my garden this year. I can see it. It's right at the top, so that's not worth me looking at the moment. Okay, I'm going to try and find something else. What was on that list, Rona, that you said? I saw it earlier. And did you get it done, Rona? Did you get the lockdown task completed? Double cluster Uranus. Oh, Andromeda. Now, anybody want to have a look at Andromeda? Now, Howie, you'll remember that one. You'll remember that one from the talk. Oh, just a quick. Have you noticed how the image has got a bit of a red background? That's because I turned the dome, and I have red lights going inside my dome, and it's actually reflected, even though I've got a black matte black paint on this. There's enough of a reflection, or my red lights are too bright, and my scope and camera's picked that up. See, there it goes. It's gone okay again. Right, I'm going to zoom out of this. I'm going to go back to Stellarium. It's okay. So, give you a change of scenery, guys. Let's see if I can work this. Okay, so we start from the Great Globular. I'm going to zoom out, and I'm going to move round so we're facing pretty much southeast. Well, east actually is where I want to go. Now, Howie, you could probably do this little bit of the talk here, because this, remember, was how I showed the audience at the PD Kirk lunches and at the observing session North Ronaldsay on the Friday night how to find the Andromeda galaxy. Now, if you look here, I'm just going to zoom in. You see this W-shaped constellation? That is Cassiopeia. And in the right-hand valley, formed by the stars Kaf, Shedar and Navi, it forms like an arrow, and I use that as a pointer. The other thing here is, you notice there are in Pegasus there are 4 stars forming an asterism called the Square of Pegasus. Shiat, Markab, I can't remember what that one's called. Algenib. And in the top left-hand corner of the square is a star called Alpheratz. So you bear off the top left star of the Square of Pegasus. You hop along the Andromeda galaxy. You hop 2 to the left and 2 up. And also using the pointer of the right-hand valley of Cassiopeia, you will come to a very faint smudge in the sky. And that is the Andromeda galaxy. Now, while I move my scope, Rona or someone will talk about the Andromeda galaxy. So, bear with me while I find this. It's Messier Object 31, and that's another whole topic. So I'm moving my scope. Hopefully you can hear the motor going. I'll turn the dome. That's a big turn. That's almost a 180-degree turn. So, big turn. So you guys can see where to find the Andromeda galaxy. Okay, now let's see if the scope and camera have picked it up. It'll be a blur. Oh. I think, guys, we have found this. Now, I'm keeping it on about a half-minute, the camera on about a half-minute exposure. What I'm going to do is let you see what's on my scope and camera. Okay, now that's like a double exposure because it's still got some of the globe cluster and some of the galaxy. that I'm pointing at. But if you just bear with me, once the 30-second exposure's up, it will be 100% the galaxy. Right. I think... Oh my goodness, I can actually see dust lanes in here. Dave, can you remember when we were looking at some of the faint galaxies up at the observatory, up at the club observatory? We were able to see dust lanes and brightnesses. I think I can actually make these out. That's it, Howie. It's like that song, what do you call it? Oh my goodness, what's that thing? Jump to the right, jump to the left, etc. Okay. Okay, I'm liking this. The sky is definitely clearing. Now, can you see the very, very bright, dense middle of the galaxy, right? That's a huge, like a condensation of stars. That's the core of the galaxy. This galaxy is huge. I mean, it's like 3 moon widths wide. And my camera, I can set this up. I can put all kinds of lens systems in that I can capture this whole thing in a full frame. It's a tricky catch, but it's excellent. There are dust lanes in this galaxy. There are areas there's condensations of stars which they're actually so dense that they're pulling in all the material and they're igniting's the wrong word, but the new stars are forming in some of these areas. Yeah, I think it's more modern than that, Howie. It's more modern than the hokey cokey. Oh, I can't remember what it's called. It's the one where all the men dress up in transvestite gear. That'll give you a clue. Allegedly. Right, I'm going to try and see if I can bring out the contrast. I'm going to give it like a full minute's exposure, so we'll just see what comes up with that. Now, let's see if I can find any information on stellarium for you. Right, this galaxy, how far away is it? Does anybody know? Oh my goodness, it is... Oh, of course I know. It's the furthest thing you can see with the naked eye. It's 2.5 million light years away. So that light has taken 2.5 million light years to get to us. And another thing, just to stop you sleeping at night, the Andromeda Galaxy and our own galaxy, the Milky Way, are on a collision course with each other. But I'm not sure of the time it will take to for us to collide with it, but I'm pretty sure humans won't exist by that time. My frame is out the screen. Okay. Right, I'm going to try. See, I haven't got this is where, Dave, I need a focal reducer on this so that I can get the thing in place, but I haven't got that with me. Right, I'm going to see what I can do. Now, I actually gave that more exposure there, and I think you can see more. Right, I'm going to give it even more exposure. I'm going to give it 90 seconds. So a minute and a half. So we'll just have to be patient while I see what I can bring out here. I'm also going to give you as full a screen as I can give you. Okay. So 1.25 minutes to go, guys. Time warp. Thank you, Gary. Have you actually attended the thing? I went to it in the McRoberts Centre in Stirling when I was in my early 20s. That was an experience. Thanks, Rona. And that's been really, really helpful, your feedback. What Dave and I are thinking of doing, it's It's a International Moon Observing Night on Saturday, and we're thinking of setting up this to take part in that. And I'm confident now that we can do this. So I'll look at all the kit and lenses I need, and Dave and I can work out a little structured observing session of the moon. Okay, 14 seconds. 14 seconds and counting. Okay. Yay! That isn't bad at all. Now, considering if I have what's called a focal reducer on this, I can fit much more of the galaxy into the frame. We're still looking very much into the heart or the core of the galaxy, but I think if you look carefully, you can see clouds. It looks like cloud structure in the bottom left of that mass, and also in the top right. Now, that's not cloud. That's dust. That's dust material between us and the galaxy. Thanks, Rona. I'll speak to you later. Bye. Thanks, Rebecca. Yeah, this is. I'm going to have to learn, like commentators do, how to keep talking while things are going on. Yeah, thanks, Howie, again. That's. I wasn't sure that the stellarium thing was going to work, because stellarium uses up a tremendous amount of computing power. But again, I have spent so much time googling, and I went onto sites that computer gamers use, so that they maximise the use of their computer processor and their graphics card processors. So I've brought the graphics card processors into play, and I think that's helped. And interestingly, Howie, this might be something that could be useful for future science festivals if we are trying to show, high resolution videos or complex graphics or something. But I'm not as techie a person as Martin. I'm a learn by doer. I'm a trial and error man. I can understand things once I do it. I tend to buy things, have a look at the manual, put it on the table, get it working of a fashion, and then I go back to the instruction manual. That's kind of my style. But yeah, thanks for that feedback, Howie. That's good. And I do think the stellarium works. And stellarium is a great bit of software. It's free. It's free for anyone using a PC, an Apple, or a laptop or anything like that. You have to pay something for it when you download it as an app, but that's only because Apple or whoever these people need money for things. So, but it's only pennies. It's £2 or £3. It's not a lot for such a good bit of software. Right, Rebecca, I'm going to give it more welly, as they say. I'm going to try and give this 2 minutes. It might grossly overexpose the core, but I want to see if it brings out more of the detail in the in the cloudy regions. Dave's just pointing out to me that the moon will be very low on Saturday, so that's a fair point. I'll check against stellarium on my apps, Dave, and make sure that I can get a view. If not, I might be going out with a chainsaw on Saturday morning and cutting down bits of trees. Yeah, just looking at comments from Howie about the Science Festival. Just for those of you who don't know, the Science Festival, it was the 30th Orkney International Science Festival, and with the lockdown and restrictions with the COVID-19 virus that's going about, we weren't sure that the Science Festival would go ahead. And how you're the main director of it, I think, aren't you? And anyway, there was a whole heap of us got together because we were so passionate about the festival, and we got together and we worked a technical way of actually delivering an extremely high quality live webcast international festival. There were speakers from all over the world. It was wonderful, and I think you did about 83 or 90 little events. I can't remember, it was something in that region anyway. It was absolutely wonderful, with a very small support team, but it was extremely good. Right, we've got about 15 seconds left. You see, I'm going to have to learn all this waffling technique. There we go. Oh, I'm quite keen to see what's here now. Oh, my goodness, actually, that is pretty damn good. That is pretty damn good. You really can see that the dusty structures in the bottom left now. Absolutely fantastic. Wow. Now, Dave will tell you that if I had that focal reducer, I think it's an F6.3, whatever it is, I would be able to fit something like 1.5 times that width of galaxy in. It would look even more stunning than what you're seeing. But what you're able to see the core, see that dense condensation of stars in the core of the galaxy. You know, that really stands out, and it gets fainter and fainter as it goes out. But it's an absolutely massive galaxy, the Andromeda galaxy. So let's see, what can I have a look at now? I'm going to pop my head out of the shutter. What can I see? Oh, Mars is still right behind that blooming willow. That's a shame. Mars is at its closest point at the moment, and you can actually see some of the detail on the surface of the planet. You can make out some of the big volcanoes. You can see the darkness, the contrast. You can see the contrast on the surface where they are. There's a little snow cap. I think it's of carbon dioxide. Dave, you might correct me, or somebody might. Is it carbon dioxide or water? Might be carbon dioxide at the South Pole, and you can distinctly see that. And that's a shame. I have got this tree in the way. Okay, what can I go for? I'll tell you what I'm going to go for. I'm going to go for one of the elements of the double cluster. So, if I go to Stellarium, now Howie, you should be able to find the double cluster as well, because that was another one I did, and you could probably do it off this. Oh, Dave's picking me. Oh, actually, I'll tell you what, Dave has made a better suggestion, and I'm going to do this. It's the Ring Nebula. Now, this is one that we do when we've been up at the observatory, and we do themes, we do star life cycles. And the Ring Nebula is something you see after a star has basically reached the end of its life. Now, I am going to go. What, Dave's pinging away there. Hang on. Right, I'm going to go to Stellarium and show you where I'm going to go. Okay, we're looking southwest. Now remember I mentioned that bright triangle of stars, Deneb, Vega and Altair, that form the asterism, the Summer Triangle. Where we're going to go this time is up to Vega in the constellation Lyra. I'm going to zoom in here. and it's called Lyra because this constellation resembles the shape of an instrument called a lyre. And there are two stars on the bottom. It's the rhombus, right? You see these four stars, they form a rhombus. And on the bottom, the base of it, there is... Right, I'm going to have to search for this. I always do. Right, F3 is the search window, I think. And I'm going to type in... Now, this is a Messier object, and it's M57. And I'm going to search for it. There it is. I'm going to put it in the centre. And here we go. Now, this is what I'm looking for. It's called the Ring Nebula. And it looks like a kind of coloured rugby ball. Okay. So, you will very soon hear my scope whir as it moves. Okay. Right. Okay, Dave, are you ready for this, since you suggested this? Oh, here we go. We're flicking from meridian to meridian. Now, I've got 10 people logged into this. Now, I've got 2 of them, so there's, including me, there must be in the region of 8 or 9 people watching this. A bit of feedback. Are people enjoying this? Is it okay? Is it interesting? Is it working for you? Oh, I can actually... The sky is cleared so much now. The Milky Way is actually clear. Right, I'm going to drop the exposure, and that is only because I can see it already. I don't know whether you guys can see this, but I've got a double exposure because as the scope was moving, I've got a bit of the Andromeda Galaxy and I've got the Ring Nebula. And the Ring Nebula is... I think it's going to be quite incredible, Dave. I think you're going to like this. Okay, Dave's opinion is the waffle is excellent. I'm sure other people may have different views on that. Okay, so we're on Stellarium. I am now going to go onto my telescope again. I have successfully found the Ring Nebula. And Dave, I think you're going to like this. Now, I've only got that in 17 seconds. I am going to bump that up to 40 seconds. This is pure guesswork, by the way. Sometimes people think I'm an expert. I am most certainly not an expert. As I say, I'm a trial and error guy. I have a go. And I learn by my mistakes. And I've made many mistakes. But it's worth having a go at anything. Okay, guys, right, we have got 20 seconds, roughly, to wait. If you look at the bottom, how I know that is see on that screen, if you look at the bottom bar, there's a little green bar counting down, and it tells you how many seconds it's been exposed and how many to go. And that's how I know how long it's got to go. And, oh, here we go. Oh, Dave. And I'll tell you something, I think you can even see the, is it the dwarf star that's in the middle of this thing? It's like a glowing cinder is the best thing. Okay, Rebecca, thank you very much. I think my wife has another name for my waffle. I think she's fed up with it after 30 years. Can you see the Ring Nebula? Yeah. Okay. It has definitely got colour in it. Now I'm going to zoom in on this. I'm going to zoom to 50%. Oh, there we go. Right, guys. Right, I have zoomed right in. I've got a bit of star trailing. Not sure why I've got that, but I have. However, there you go. Can you see that okay, guys? Awesome. I always know it's Dave when he says awesome because he spells it O-S-O-M. It took me a while to work out. I thought it was an abbreviation for something once, and it's not as clever as that. It's okay. That is good. Now you see the colours there. That's the as the star got to the end of its life. Right, stars fuse hydrogen to form helium, and then eventually the helium fuses to form other elements, and so on and so forth. If you look at your periodic table and you basically traverse through that, you'll see the series. It's not quite as simple as that, but you'll see the series of elements as they form. And stars, I think they can get up to, is it about carbon or iron? I can't remember. Anyway, they get up to a point where they can't fuse anymore, and they don't produce enough energy to keep their star shape, and the gravity then it falls in on itself, and it just falls in. The gravity just collapses the star, and depending on their size, this one eventually just collapsed in itself to form a very dense dwarf star. Now that dwarf star isn't actually producing new energy. All it is, it's trapped the energy it made, and it's just dispersing itself out until it will eventually use up that energy, or it'll go into space and it'll eventually just fade away. But there's enough wind, there's enough energy that is blowing the elements that were formed during the life cycle during the lifetime of the star, and they're going out. Now we're looking at this in 2 dimensions. It looks like a rugby ball, and it is much more like a rugby ball. So that star, the energy from it is blowing out the elements in a big balloon, or a rugby ball shaped balloon. There are different colours. There are greens, there are yellows and reds that we can see, or my camera can pick up. And those are basically concentrations of different elements. Now eventually those elements might collide with elements from other blown up stars, and they might eventually form, little dust clouds, and then they might coalesce and form planetoids around new forming stars. And that is how we have minerals like platinum and gold and iron and all kinds of things on our Earth, and indeed in ourselves. There's somebody once coined the phrase, we're all made of star stuff. So we are formed from previous stars that have gone through their life cycle and blasted out into space and then collided with other stuff. Quite fascinating. Okay, now Dave says I should give this a bit more whirly. I'm going to give it a minute. We'll see if we get anything else out of this. Might not. We'll try. Cool. Right, 45 seconds. I wonder if Stellarium has any information. Okay. Oh my goodness, that ring nebula isn't that far from us. It's only 199 light years. So if you could travel at the speed of light, take you roughly 200 years to get there. Let's see. Right, it's got a magnitude of about 11. That's not. It's not overly bright, but it's also not overly dull. That's perfectly feasible to pick up in a small telescope. This camera set, the setup I have, I've got an 11-inch wide objective telescope, and then with a very, very sensitive, highly specific astro camera I've got attached to the end of it, I can pick up really faint things. I'm not sure the limit, Dave. Dave might be able to tell me. He likes those kind of numbers, but very faint indeed. Okay, there's a minute's exposure, guys. I'm going to play about with the colours and see if I can emphasise anything. Oh, definitely went the wrong way there, guys. That's not bad. Now, thanks, Gary. When I do my astrophotography, I have a whole set of specialised filters, and I can use those filters to select certain wavelengths of light, which help, bring out or show me different features of the objects I'm looking at. It's a bit like false colour, but you see some fascinating things as we get later on in the observing. I mean, we're right at the beginning of our peak observing time now. So this is when we would be starting to do our normal weekend observing sessions, and as we get towards like November, December, there are some wonderful nebula that you can see. The ones like I got photographs of the Heart Nebula and the Soul Nebula last March. It was in actual fact, and you can see using the filters wonderful areas of they're very red. I have filters that bring out redness, and that's hydrogen, clouds of hydrogen gas from which new stars form. I've got oxygen filters. I've got a new sulfur, an S3 filter, which I haven't used yet, Dave. So hopefully that will bring out blue and yellow colours, and I can't remember the elements. Well, it's probably sulfur. So it'll bring out those elements and those nebula that I haven't seen as yet. So I'm really, really looking forward to using those. But we should be able to use them on this type of live webcast. So if I, for example, was looking at the Ring Nebula and I put a different type of filter on there, it would allow you to see some of the structure that is currently invisible using this optical setup. So, as I say, I don't fully understand the science behind it. I can easily find out, and I will find out, because I'm terrible for somebody asks me a question. I can't leave it. I have to Google it or research it in my textbooks later on. Okay, right guys, I'm going to go on to another nebula. Dave, can you guess which nebula I might be going on to? Weird Star stuff was Carol saving. Thanks, Dave. And Dave saying the colour is great. Yeah, I can see it now. Actually, on the iPad, the colour looks much better than on my laptop. So that's something I'm going to have to remember this, that I think I'm going to need to refer to my tablet, my iPad, because it's definitely given a much, what I would call truer colour that I see on my photographs. Whereas my laptop, it must be the way I've got it set up, it's definitely got a yellow or a green slight background tinge to it. Oh, and Dave's also reminding me, there's a wonderful nebula. It's probably everybody's favourite, the Orion Nebula M42, and Dave had a light pollution filter, and it brought out tendrils. There was structure that we weren't able to see. Right, guys, I'm going to go on to Stellarium once more, and I'm going to show you another nebula, which is not too far away from this one. So that was Messier Object 57. I am going to go and find Messier Object M27. And it has the name, I just saw a satellite creeping into It has the name the Dumbbell Nebula. So again, it's now. I don't know whether you've noticed, right? So I'm talking about this area. So it's the same area. So we're in the south-southwest region. There are these three bright stars: Deneb in the constellation Cygnus, Vega in the constellation Lyra, and Altair in the constellation Aquila, the Eagle, and it forms that summer triangle shape. If you notice, those three constellations are all in the line of the Milky Way. You see the Milky Way, that smudge, that cloudy smudge, that's the Milky Way. You are looking through one of the spiral arms of our own galaxy, the Milky Way. And it's in this spiral arm region where there are nebula of new star formation, of dead stars. There's a whole heap of stuff goes on in this spiral arm. That's why it's so popular with especially amateur astronomers. So where that little square is flashing away, this is where I'm going for the Dumbbell Nebula. I'm going to zoom in, and you will see it. They call it the Dumbbell Nebula. My daughter, when she was young, I showed her this through the eyepiece, and she could have only been about 11, 12 years old, and she described it as an apple core. And you know what it is? I think that's, to be honest with you, a much better description. Okay, I'm going to set my scope to find Messier Object 27. It shouldn't take long to find this one. Okay, right, I'm just going to check my laptop and see if we have found it. I'll drop the exposure time because I only want to see whether it's in the frame, to be honest with you. And then I'll start to muck about with the exposure to bring out the details. I think it needs longer than 12 seconds. Aha, I think I've seen it. Right, I'm giving it half a minute. So I'm looking at Stellarium, and this one, it's actually very similar distance away to the Ring Nebula. The Ring Nebula was 199 light years away. This one is 163 light years, so I suppose in astronomical terms, that's pretty damn close, to be honest with you. And this one has a magnitude, so a brightness of 11.3, whereas the Ring Nebula was a magnitude of about 10. That means that this one is fainter overall. The higher the number, the fainter the object. Right, I'll better let you see what I'm looking through in the telescope. Okay, here we go. So get rid of Stellarium, and we'll bring in this. Okay. Oh, now I know this is going to be good. Dave, I think you're going to like this. I can already see the apple core or the dumbbell structure. Okay, Rebecca, thank you for coming in, and thank you for your comments. I think you found that by looking at our Highlands Astronomical Society Facebook page. So I'll be putting these things, certainly, for the next few anyway, I'll be putting them on the Facebook page. Our members will be getting emails as well. And I'll possibly put it, I don't know whether I'll put it on Twitter or whatever, but anyway, we'll make sure that you get to know what we're going to be doing, and if you've got the time, great. The other thing, Rebecca, is I'm recording these just now, so if you can't look at them, at the time live, I'll certainly, for members, I'll be sending out the link. But I can't remember if you remember or not, Rebecca. But if you're not, just drop me a message and I'll send a link to you since you've played a part in doing this one for us. Okay. But anyway, thanks for your contribution. It really has been helpful. Right, I'm going to bump this one up to I am going to give it 80 seconds because I think this one needs it. You should see on the outer bits of the apple core, it should be a kind of red, a blood red almost colour. Okay, so we'll just have to hand fire. Still got a minute to go. This again, these are all favourite objects. See when you're first taking up astronomy and when you are starting to use a telescope. Not that I recommend a telescope for beginners, but once you start using a telescope, these are the objects, the Messier objects I've been talking about, that we help teach and train budding amateurs to find. They're great things. They're great things to try and hunt down, and they're actually very interesting to find out what what processes have brought them about. It's a great way of learning learning astronomy. So how long have we got to go? Well, I can see we're 12 seconds. 12 seconds to go, guys. Don't know whether Rebecca's held back for this. Oh, here we go, here we go. Oh, that is actually, I have to say, I am quite pleased with this one. In fact, I'm very pleased. I definitely don't think it's a dumbbell. I think my daughter's description of apple core is much, much more apt. That's wonderful. I can actually see, I can see the colour. There's a bit of structure there as well, with a bit more refinement and practice with this. Can you see it, guys? Oh, if I can get the contrast up. Oh, there must be a way of doing this. I'll tell you what I'm going to do. I am actually going to try and zoom in on this a bit. Oh my goodness me. Okay, it makes the stars look as though they're trailing a bit, but you can definitely see some structure in here. Okay, how can I get contrast? It must be something to do with this. No, definitely not that way. Whoa. Whoa. Now, red's a bit high. Let's get that down. I'm going to take the gain down. Just a fraction. Can you guys see this okay? Okay. Can you see that? I think that is particularly stunning. And I'm just looking at the time, and I think I am going to call it a night if that's okay. Just thank you very much for making the effort to attend and giving me some feedback. It's been really useful. Dave and I will chat tomorrow, and we will work out how to develop this for webcasting to members. I think it's wonderful that we can do this because we're in a difficult situation where, we are an amateur astronomy club, and one of the things of any club, let alone astronomy clubs, is for people to get together, socialise, chat about a common interest. The other one is there's a group of us, we're very, very enthusiastic, practical observers, and we love showing the night objects in the night sky to people. And we thought we weren't going to be able to do this. And you know what? I think this is a damn good way of bringing the night sky to people. And in actual fact, with the technology, I'm there. With the technology, you can actually see features in the objects that you can't see through an eyepiece. Oh, hello, Pat. I didn't know you were there. You've been lurking on your new computer. Okay, guys, I am going to close off. I've got a little closing slide. This is our little professional thing that we do. Okay. So I'm just going to set ourselves going. I just want to say thank you very, very much for making the effort to attend. I've enjoyed it. I really have enjoyed it. You can probably tell I am very enthusiastic now, and I can't wait to sort out the tiny little glitches that we have to sort out. But anyway, thank you very much. Goodbye. Clear skies. See you again.